All right. Well, we can go ahead and get started. Greetings, fellow scientists. I'd like to welcome you all to the Wisconsin Science Festival online field trip tour through a modern cheese plant. Thank you all for joining us today. We are ready to get started. My name is Sam from the Wisconsin Science Festival team, and we're here with our special guest, Luke Buchholzer from the Klondike Cheese Company in Monroe, Wisconsin for this field trip. So how can you participate today? Well, you'll notice that your picture and audio are muted and that the chat isn't available. But if you have any questions you'd like to ask, you can use the Q&A feature. As soon as you have a question, go ahead and type it in right away, and we'll ask your question for you out loud during the field trip. So this field trip will be recorded, and as always, we ask that you do this and all activities in the Wisconsin Science Festival with a responsible adult. We'd also like to thank all of our sponsors and partners that help make the Wisconsin Science Festival possible. You can find out more about our activities and events during the festival at wisconsinsciencefest.org. And with that, we're excited to get started. So Luke, are you ready to go?
Yep, I am ready.
All right, so just as a reminder, folks, as you're signing in, to put any questions that you have for Luke in the Q&A section down below at the bottom of your screen. So Luke, why don't we start off by having you tell us a little bit about who you are and your background and how you got into cheese making.
So I'm Luke Buchholzer. I am part of the fourth generation of Buchholzers at Klondike. So about me, I actually grew up at the plant. So it's an old Swiss tradition for the cheesemaker to live directly above the cheese factory. And my dad is the oldest of the three brothers, so he got the house when my grandparents moved out. So yeah, I've been around the factory my entire life. It's really been something that I always wanted to pursue. You know, once I realized that just because I wanted to be an astronaut didn't mean I got to become an astronaut. But no, I've always loved cheese making. So kind of a short history of my family is my great-grandfather emigrated from Switzerland and became a cheesemaker at Klondike. At the time, it was a co-op. So that meant the farmers owned the building and the cheesemaker owned the equipment, which there wasn't a lot of equipment back then. It was just a kettle, more or less. Great-grandpa ran the cheese factory until my grandfather came back from World War II and took over. Then my dad and uncles got into the business. At that time, the farmers didn't want to be a co-op anymore, so we bought out their assets and changed it from a co-op to privately held. Now, kind of fast forward today, my dad and both my uncles are still active, and all three of them are master cheesemakers. And then there's myself, my two cousins, and their spouses involved in the business. So we got almost the entire family involved.
Yeah, it's definitely a family affair for sure. How many total employees do you have at the factory?
We have around 220.
Okay. Wow. That was one of my questions. And we already have a question from Vanessa in the Q&A, which is probably the first thing any cheesemaker gets asked is what is your favorite kind of cheese?
So it kind of depends on what I'm doing with it. I love cooking with feta. It brings out a lot of flavor that's unique to dishes. For just, a table cheese to snack on, there's so many cheeses and they all have different flavors. It's like kind of picking your best, your favorite candy. Do you want chocolate or do you want gummy bears? They're all good. Munster, good cheddars, some cheap milk cheeses like Manchego are very good.
Yeah, I mean, it depends on the day. For me too, right? I love me a good cheddar. That's for sure. So I watched the video, the tour of your cheese plant myself, and have lots of questions about what all goes into cheese making. But maybe just in case anybody didn't watch the video that's watching here today, could you give us like a brief overview of the few major components that goes into cheese making?
Yeah, so some of the things that go into making almost every kind of cheese, you start with milk, obviously. Then you add the starter culture, which is your good bacteria, and that does a lot to determine the flavor of your cheese. Then you add the rennet, which is an enzyme which actually makes the milk gel together, kind of like what Jello does. Completely different science, but similar texture. Then, then you cut that gel, and that's when you start getting your separation of your curd and your whey. And then the curd goes into a form of some type. And then after a certain period of time, and all these are variables for different types of cheeses. Like the Munster that we make, it's in its form for 2 hours. The feta that we make is in its form for 24 hours. And so all these changes help determine the type of cheese that you get. So then it goes into a form. Some cheeses you salt the curd. You add salt directly to the curd. Other cheeses you actually put into a brine bath to get the salt. And then after that, it goes into packaging or aging. Again, all these, those are the very basic steps going to pretty much every cheese. But that's how we can have over 600 types of cheese when we have the same ingredients in all of them.
Right. Yeah, definitely. And one of my questions too was, what kind of milk do you use at your factory to make your cheese?
So all of the cheese that we make, we use cow's milk. Even the feta. Feta is traditionally a sheep's milk cheese, but sheep's milk is much more expensive in the United States than it is in Europe. So it's always been cost prohibitive for us. But with the additions of different starter cultures, we've been able to get the flavor profile that we want.
All right. Yeah, it's interesting to think about the different flavors and things that you can make with the same ingredients. I know you specialize in feta. Do you have different recipes and ingredients and flavors of the feta that you make?
So we have tweaks that we make throughout the year to adjust for the seasonality of the milk. So the components in the milk change throughout the years. When it's warmer, the cows drink more water, the milk gets more watered down, so we have to make changes to that. But what we do is we try to make the absolute best. So what we make every day is basically the same recipe. We have some different rotations of starter culture, but we really try to say the cheese that we make on Monday is the same cheese as we're going to make on Wednesday, and that way what you're buying at the store is always the same.
Right. Yeah. You talked a little bit in the video about the pH of cheese. Can you talk a little bit more about how that is tested and regulated and why that's so important?
So the pH, how we test that today is we actually have pH meters. They're just little probes, little glass probes, and you put it on the surface of the cheese, and that'll give you a pH reading. The pH is important in the cheese because not only does it gives you an indication of how fast the starter culture is moving, it also helps determine your flavor, and also it does a lot of things to the body of the cheese. So feta is a firm, but it's crumbly, and if you don't get the pH low enough, it actually starts making isoelectric bonds at a low pH. And if you don't get low enough, it doesn't make those bonds. So instead of having a crumbly yet creamy feta, you wind up, it's just kind of floppy. And the same thing, for the Munster we make. It has a very smooth body. If we let that pH get too low, then it gets really brittle.
Right. And does that factor into the aging of cheese as well?
No, the aging of cheese, that really is to give the starter culture more time to develop that flavor. So as cheese ages, that starter culture still has time to just make more flavor, so it gets bolder. Mm. Also, other things happen to the body. You get some breakdown of the body. The fancy term for that is proteolysis. But the pH in your make, whether you're going to age that cheese out, because it affects the body so much also that you don't want to get too far out of range if you're going to age it. Even 3 want to match it up. Aged cheese and fresh cheese are of the same type. Are going to have very similar pHs.
Sure. And we had a question in the chat. How old can cheese get?
That, it can get pretty old. I myself, I've had cheddar that was 14 years old. Usually what determines the maximum age of cheese is, again, what'll happen is as it ages, all the flavors develop. So if there's an off flavor in there, that'll start coming out too. So that's why you can't take, we'll just go with cheddar. You can age any cheddar, but a block from this vat may not make it at 7 years, may not taste any good.
Mm. Do you, when you're aging cheese, do you test that along the way? Do you taste it every few months, or?
Now the cheeses that we make, we actually age, but I do know that in an aging program, they do actually grade the cheese at different variables, and a good grader can actually taste this cheese and go, no, we can age this longer, or no, this one we should sell within 6 months, because it'll kind of tip over the edge of the flavor profile.
Right. So there is that job out there that somebody just eats cheese for a living.
Yeah, actually. So in Wisconsin, you can get a cheese grading license.
Wow, that's awesome. I would love that job. I want to talk a little bit more too about your plant. There's so many fascinating things about the tour that you gave us on the video. I was really fascinated by the coagulator machine, this sort of central piece of equipment as you referenced it as. I'm curious, because it is such a central piece of equipment, what happens when things go wrong or if it breaks?
If it breaks, nothing happens till we get it fixed. So we're blessed as a family. Besides being good cheesemakers, we're also really good mechanics. So, with that, we keep a lot of spare parts around. Basically, there's almost nothing that we don't have a spare part of. From air cylinders to even the belt that makes that drives around the coagulator that we actually make cheese on. That there's a spare that's kept over by Milwaukee for us.
I would imagine that's a fairly long belt.
Yeah, it's 127 meters.
Wow. That you could tell from the video that the coagulator was a large machine. That's fascinating. And you did mention too that you had robots at your plant. Can you talk a little bit more about the process involved in getting those robots to know exactly what to do just for your particular plant and the cheese that those robots are helping make?
Yeah, so we have everything from very simple, like kind of 2D robots to all the way up to 5-axis robots. So it really starts with the integrator, going to the integrator and, okay, this is what we have, this is what we want. Then they'll design a cell. So when you have a robot, generally it's referred to as a cell. When the product enters the cell, that's where the robot can actually touch it. So then they'll start designing that. You give them the parameters that you want to work with. So a couple of the robots that we have are to put our retail crumble cups into boxes. So we have 3 different size cups. And so we have to design all that in there. And it really is just back and forth with the whoever's making the robot about really defining what you need it to do, any variables that are in the process. And the worst thing you can do is to act like your process has fewer variables than it is, because then you'll actually run into it in the real world. And robots are incredibly dumb. They only do exactly what you tell them to do. So if it didn't know that it's supposed to account for an extra inch of height, it'll stop. So no, we've put those in. It really is, it's not to reduce the employee count. It's to make a job better. So wherever you have a robot, you generally have someone watching the robot. I know there's places that like to tout, they can just turn off their lights and walk away. What I've learned in cheese factories is you really can't do that. You still need somebody to watch it. So we just took away the actual putting of the cups in the box, which was giving people wrist problems. And now they just watch it and they load the box magazines and things like that.
Yeah, I would imagine that. Is there like an emergency shutdown or something like that, that if a robot isn't doing the job correctly, that the person watching the robot can just kind of stop things where they're at?
Yeah, there is. But generally the robots are built, you know, if they run into something, they're not, they might crack a cup, but they're not going to like really bend too much. They usually have stops built in, but yeah, there's emergency stops. For our robot cells, we actually use what are called light curtains. So it's laser beams that shoot back and forth, and if you break that, it acts as an emergency stop.
Interesting. So when you first had the thought of adding robots to the process, how long of a time frame is that back and forth period with the integrator, and you know, did you know it was going to work right away and you put them in, or did you have to tweak things as you went?
Well, any equipment, you always, after you put it in, you always got to make some tweaks to it. But as far as the timeline went, from the day that we signed the PO that, yes, we were, you know, the purchase order that, yes, we're going to do this, to when we had them in was roughly, it was close to a year. Because the ones that we got were the very first ones that were ever built. So they had to design the conveyors. There was nothing they could say, this worked before, we'll put it here. Every single thing had to be tested and figured out.
Does that testing happen at your plant, or is that where they're building the robots?
They do a lot of the testing at their facility. Generally they have all their tools there, their fabrication equipment. I mean, they had to start, you know, from the very first conveyor. But yes, so the vast majority of testing happens at a equipment manufacturer's site. Then the only testing that happens when it gets installed in our factory is really just, you know, everything should be proven out more or less. Now it's just getting the speeds and everything dialed in with actual product.
Right. Is that equipment manufacturer local to Wisconsin?
The one for the robots, yeah, they're actually right in Monroe. It's called Quest Industrial.
Awesome. So that probably made it a little bit easier in the process that they were close.
Well, yeah, you know, so if there were any questions, I mean, we could just, you know, just drive to town. It was a 7-mile drive.
That's awesome. Cool. We do have a couple more questions in the chat. So talking a little bit more about the cheese itself, we had a question from Dan. So why does some of the cheese smell different than other cheese?
That's a couple things. If it's aged, it'll have a more pungent flavor. Depends on the milk that's used, lipase enzymes that are used. Also, there's some cheeses that they're defined as smear ripened, which means they'll put bacteria on the outside of the cheese to help develop the flavor, which also increases the smell of the cheese.
Like a Limburger, I know, is a stinky cheese. Great. We had a question in the chat from Becky, and just a reminder to everybody else that's watching, feel free to add any questions that you have for Luke in the Q&A section down below at the bottom of your screen. Becky's question was, have you seen any difference in the demand for cheese with COVID?
We have seen, yes, in a couple different ways. So we supply both cheese for restaurants and for industrial use and retail. So we've obviously seen the demand on the retail side increase and the demand on the food service restaurant side decrease. We've also seen just, I haven't seen hard numbers, but just what it seems like is the cheeses that would normally be used for a cheese platter, in a fancy restaurant, the demand for those cheeses is down, whereas the cheeses that are used for cooking, easy things at home, the demand for those seems to be above normal.
So it kind of just depends on where we're eating the cheese almost.
Yes, very much.
Awesome. We have a question in the chat from Izzy, who is wondering, do you make any other dairy products besides your feta?
Yeah, so we make feta, brick, Munster, Havarti, Gouda, and Greek yogurt.
Awesome. And I do remember seeing that part in the video about the yogurt. How is that process? I mean, yogurt and cheese are two very different things. What's the main difference in that process?
So the main difference is there's no rennet in yogurt. So what makes yogurt stiffer than milk is it actually goes through a heating process, and we denature some of the proteins, and those proteins want to stick together. So I mean that's the big difference in the make is it's and we homogenize the milk. So making yogurt, homogenize the milk, you pasteurize it, then you heat treat it. We actually run ours up to 190 degrees. Then we put it in a ferment vessel. We add starter culture, and it'll thicken up in that ferment vessel as the pH drops. And then when we get the pH one we're looking for, we'll stir that yogurt and then pump it into its container.
All right, just like we buy in the store.
Yes.
And I know yogurt comes in lots of different flavors. How much time do you spend at your plant thinking and tweaking and making different flavors and recipes?
Actually quite a bit. We do actually quite a bit of custom work. So one of the areas that we service isn't the yogurt that you would buy in the store. It actually people use as an ingredient. So they need, for whatever their application is, they'll need varying protein levels, pH levels. So we actually do have a little R&D set up where we can make 200 pounds of yogurt at a crack instead of our normal size is 18,000 pounds.
So you can do small batches to see on flavor.
Yes.
To test different flavors. That makes a lot of sense. And that kind of leads to the research and development part of it. But do you collaborate with other cheesemakers or share techniques?
Generally not. As far as, some overall stuff, real broad scope, there's not really a need. Any accomplished cheesemaker already has those. But the real fine-tuned stuff, we do kind of keep those as trade secrets. But one thing everyone in the industry is pretty open about is cleaning, sanitation, and making sure that, we're making safe cheese. Everyone's pretty open about what they do there.
Awesome. Yeah, that makes a lot of sense too. One other question too, we're about out of time. We have about 6 minutes left, but one other question is, what do you do with the leftover whey?
So nobody just throws the whey away. What we do is we do a multi-part process. So the first thing we do is we run the whey through a separator. We pull the whey cream off, and then we sell that to a creamery that makes butter with it. That goes through an ultrafiltration system, and that filters out the protein. We concentrate the protein up to 35%, and then we sell that to another company that'll make it into a finished product, whether it be pharmaceuticals, baby formula, weightlifting powder. They do that. Then what comes off the ultrafiltration system, we send through a reverse osmosis system, pull the lactose out, and that gets sent off to make animal feed. And then what's left over, we actually treat that in our own wastewater treatment facility, and we irrigate that onto fields to grow more alfalfa to feed the cows to make more milk.
That's a wonderful circle then. So nothing goes to waste, it sounds like. That's fantastic. Um, we have a couple other questions in the chat. Gerard wants to know, do you guys ever host events for folks to come to your factory?
No, in today's age of food safety, we pretty much consider everyone from outside the plant to be dirty, and we don't want them in the plant.
That makes a lot of sense too, especially nowadays. And another question from Dan, why does cheese have different colors?
That has a lot to do with the aging process, but then also there's something called annatto color. It's a vegetable seed extract, and cheesemakers have been using it for, cheesemakers have been coloring cheese for hundreds and hundreds of years. Generally, like a cheddar, we add, to make cheddar orange, color is added to that. You add it right to the milk. Munster is orange on the outside because of the annatto color. Some cheeses, it'll be the aging process that adds a little bit of hue to it, but the cheeses that are orange generally have some annatto color in them.
I do remember that a true cheddar is white, correct?
Yeah, basically since all cheeses you're starting with white milk, that's what you're starting with. So if you don't do anything to it, it's going to be white.
Right, that's interesting. So with the few minutes we have left, I want to make sure we're getting to as many questions as we can. It looks like a lot of folks are interested to know, what is your favorite type of cheese?
Probably day to day, just for snacking on it would be Munster.
Interesting. And what, make sure we got all of them in there. What is your favorite part about, we'll make this the last question because we're almost out of time. What is your favorite part about what you do?
I think it's the whole, just being able to create something high quality every day. And it also, being a cheesemaker, we're looking at new equipment and new processes, and so there's new stuff all the time.
So a normal day at the cheese plant is different every day.
Yes, there's no normal day at the cheese plant.
That's wonderful. Luke, I think that's all we have time for today. Is there anything else that you'd like to mention before we head out?
No, just I guess a fun fact for our factory, we need about 25,000 cows for the milk that we use every day.
That's a lot of cows. That's fantastic. And I think you mentioned in the video, but how much cheese do you make per day? How many pounds?
On the feta side, we're making about 130,000 pounds a day. Munster Brick and Havarti, we're doing about 55,000 pounds a day.
That's a lot, a lot of cheese. And to put it into perspective, how much, like a normal cup that we would keep in our house in our fridge, how much is that compared to what?
That's about 6 ounces.
6 ounces versus 130,000 pounds?
Yeah.
That's a lot of cheese. Well, I think that's all we have time for again today. So Luke, I want to thank you for joining us here today, and thank all of our participants who are watching. The Wisconsin Science Festival continues the rest of this weekend, and a recording of this field trip will be available later on this weekend, and we will follow up with all of the teachers who are participating with that information. And then remember, again, the Wisconsin Science Festival continues with events hosted from organizations all across the state that you can participate in. So just check out wisconsinsciencefest.org for more fun science. So thanks again, Luke, and thank you all for watching. And we hope to see you at either other field trips today or some of our other Science Festival events.